Jai Hind everyone. So my name is Ritika Dhyani. I work in AKGEC college and my video lecture is on the topic Propositional Logic and Theory of Inference. So first of all, what is a propositional logic? A proposition is the basic building block of logic. It is defined as a declarative sentence which is either true or false, but cannot be both. So when the value is true, we denote it using the capital T letter, and when the value is false, we denote it using the capital F letter. For example, here as we can see, 5 plus 2 equals to 7. Of course, this will result in true value. So yes, it is a proposition. Secondly, bananas are green. We know bananas cannot be in green color. It can be either in yellow color or light yellow color. So this statement is also false. So yes, it can result in the false statement. Third one is 5 and 5 makes 8. This we know 5 plus 5 is equals to 10. So this statement is also false. Yes, it is a proposition because it results in a false value. Last one is a is less than 2. As we can see, if we put a equals to 5, so this will result in false if we put a equals to 5 because 5 is not less than 2. If we put a equals to 1, then this statement will result in true. But as we see, a single statement cannot handle both true and false values. So this statement is not considered as a proposition here. Moving on to the types of proposition. First one is atomic proposition. In atomic proposition, we have only individual statements which is either true or false. But in case of the compound propositions, we have connectors which combines two or more statements which results definitely in true or false. For example, as we can see here, this is a single statement, 5 plus 3 equals to 8. And in the second statement, sun rises in the west. Both of these statements results in either true or false, and these are individual statements. So these are the examples of atomic propositions. Next, if we can see here, compound propositions. We have again 5 plus 3 equals to 8. And this is the connector for this compound proposition. We have another statement which is 5 minus 3 equals to 2. So these are two statements which are combined using connector. So this is an example of compound proposition. Next, what are the connectors that we can use in propositions? So basically we have 5 connectors. First one is or, second is and, third one is negation, fourth is implication, which is also called conditional or if and then statement. Fifth one is by implication, which is also called biconditional or if and only if is used in a particular statement, then that statement is known as biconditional statement. First one is or. So or operator, basically when the inputs of two variables or propositions are at least one of them is true, then result of this operation is also true in that case only. For example, here we have, suppose we have one of these proposition as A and the second proposition as B, then if both A and B are false, then this will result in false only, and we denote or using this particular symbol. In the second line, we can see one of the value is true. If one of the value is true, then the results is true. Again, in third case, we can see A results in true, but B is false. Again, this will result in true. And the last one is both of the propositions are true, then of course the result is true for OR operator. Next one is AND operation. AND operation is basically true when both of the propositions are true. In that case, only the results is true. Otherwise, the result is false. As we can see here, both of the propositions are false. So, AND operation results in false here. Here we have one of the value we have as false. So, of course, this will also result in false. Third one is, again, value of B is false. So, this case is also results in false. In the last case is when both of the propositions are true. In this particular case, the AND operation value is true. Next is negation. This will simply reverse or swap the values. Basically, what it does is, when a proposition is true, it results in false, and when the proposition is false, then it results in true. So, if we have a proposition A here, then if A value is false, then negation of A will result in true, and when the value is true, then it results in false. Fourth one is conditional or implication. It basically is false in a single case where the first proposition is true and second proposition is false. In this particular case, it is false. Otherwise, all the cases, it results in true only. So, let's see. In this particular case, the value of implication is false. Otherwise it is true. For here, it is true. In all rest of the cases, the value is true. Only in this particular case, the value is false. Also, there is one major point that you need to remember is the logical equivalence of implication. X implies Y is negation of X or Y. You need to remember this because in exam, whenever the question arises, you need to solve the implication. Then first way of solving this particular question is using the truth table. Again, if truth table cannot be used, then in that particular case, you can use the law of algebra, and for that we replace this implication with not of X or Y. Fifth one is biconditional. As we can see, this is the symbol for biconditional. It is a logical connective which is true when P and Q are same. What does it mean? It means if both of the values of the propositions are either results in true or in false, then in that particular case, this particular operation results in true. Otherwise, it is false. Let's see here. Suppose we have two propositions. In the first case, both of the values are false, or we can see both of the values of propositions are basically same. So it will result in true here. And in the last case, we can see both of the propositions are true. So it will also result in true. Rest of the cases, it results in false. Secondly, the logical equivalence for this particular biconditional operator is we can replace this by this statement. The result of this particular statement is same as the result of biconditional. Some example, let's see here. First, either you leave or I'll tell my parents. So here we can see this is the proposition. Let's suppose it is P, one of the statement, and the second statement is I will tell my parents. So let's say this is Q. So in this case, we can write it as P or Q. Secondly, neither Harry nor Jack is responsible for this mistake. So the first statement can be Harry is responsible for this mistake. This we can write as P. And the second statement will be Jack is responsible for this mistake. So we can write it as Q. If we take this Harry is responsible for this mistake as P proposition and Jack is responsible for this mistake as Q's proposition, then we can write this sentence in the form where neither P nor Q. We can write it as this way. Thirdly, if I study hard, then I'll get good marks on the exam. So if we take this particular statement as P, if I study hard, and this statement as Q, then we can write this particular statement as P implies Q, because if I study hard, then only I'll get the good marks. So this is the if, and then as we can see here is already mentioned, then this is the statement for implication. So we can write it as P implies Q. Last one is I'll go to the office if and only if Jack is coming. So I'll go to the office can be considered as P statement and Jack is coming can be considered as Q statement. Then we can write it as P biconditional Q, because as we can see, if and only if is used in between these two statements. So this represents the biconditional operator. Moving on to the next topic, that is the tautology. A tautology is a formula which is always true for every value of its propositional variables. What does it mean? Whenever a particular proposition results in only true, then or in every cases, then only it is known as the tautology. Let's see it using an example. Here we can see we are given A and B and 4 of the cases, then check whether this particular proposition is a tautology or not. Let's firstly we find out from the inner bracket, that is A implies B. We know in implication only the false value is this one, rest the cases are true. Moving on to if we apply AND operator between this implication and A, then we get A implies B and A. The result is we need to compare these two values. For AND operation, then false true, it will result in false. False true, of course false. True false, false. And in the last case, both of the values are true, so it will result in true. Lastly, we need to find with this particular proposition, if this is what we actually need to find, implies B. We need to apply this result along with B proposition, then F false will result in false. This will result in true. False true. In implication, only condition is true false result in false. So let's see. False false, true. False true, true. False false, true. And true true, of course, true. So as we can see, the result is always true whether the inputs are false or true. So yes, it is a tautology. Moving on to the contradiction. A contradiction is a formula which is always false for every value of its propositional variable. In contrast with tautology, the result is always true, but in this case, the result is always false. Let's see it with an example. We need to check if this particular statement is a contradiction or not. Let's see. Firstly, let's find out A or B. A or B. So here we have false false, it will result in false. If one of the value is true, then in this case the result is true. So here it is true, true for true false it is true, and the last one, it is true. Nextly, let's find out negation of A. Negation of A is, for F, we have true. Again, F, true. Then the value is true. The result is false. And last one is false. We have already found out. Let's find out the next one is negation of B. Negation of B is, here the input is false, so it will result in true, then false, again true, and false. Now we need to perform AND operator between these three results. Let's find out the result here. So it will be, for AND operator, if in all the cases the value is true, in that particular case the it results in true, otherwise it is false. So here we can see this particular is false, so the result is false. Here this one is false, so the result is false. Here negation of A is false, so the result is false. Here two values are false, so the result is false. So here we can see, in all the four cases it results in false, so yes, it is a contradiction. Next one is contingency. A contingency is a formula which has both true and some true and some false value for every value of its propositional variables. Basically, it is a mixture of both true and false results. Let's find out here. Firstly, we need to find A or B. Here we can see A or B will result here false, then true because one of the value is true, again true, and the last one is true. Next, we need to find negation of A. Negation of A will be, for false it is true, for false it is true, again for true it is false. Then we need to perform AND operation between these two results. So A or B and negation of A. If we perform AND operation, then we can see if one of the value is false, it will result in false. So yes, it is false. In this case, it is true. Here it is false, and here it is false. As we can see, the result is a mixture of true and false both. So yes, it is a contingency. Nextly, we have converse, inverse, and contrapositive. Whenever we have a conditional statement, X implies Y, then we can find the converse of this statement by just swap these. To find the converse, inverse, and contrapositive of a particular conditional statement, we have, for example, we have X implies Y. Then the converse of this particular statement is Y implies X. Just swap both of these values. And in case of inverse, we have negation of X implies negation of Y. And in contrapositive, we have swapping the both of the values and also performing the negation. So here we have negation of Y implies negation of X. Let's see it using an example. So let's have, for example, here we have, if you do your homework, you will not be punished. For example, this is, if you do your homework, this is a statement P or X, let's say, and you will not be punished is Y. Then the converse of this particular statement is Y implies X. So here we can write, if you will not be punished, you do your homework. Just reverse the statement in case of converse. Next, inverse of this particular statement is perform the negation of both in X and Y and then do the implication. So here we can do, if you do not do your homework, this is what? This is the negation of X, and you will be punished because Y is you will not be punished. So the negation of Y will be negation of you will be punished. So this is the result of inverse statement. Lastly, we have the contrapositive statement where we perform both implication and swapping and negation of both of the propositions. So here we have, for this particular statement, we have X implies Y. So This will result in contrapositive results in negation of y implies negation of x. Here we have, if you are punished, you did not do your homework. So we can see negation of y is if you are punished, and negation of x will be if you did not do your homework. So this is the final result for this contrapositive statement. Thank you.